Let me give you another example of a speed time graph. So when you're given any graph, your eye should zoom into this bit here. So here, well, your eye should zoom into here, just so that you know what the graph is talking about. Here, the graph is talking about speed, and then your eye should zoom in into this part here. It's speed against time. So this is as time goes by, or as time increases here. And then your eye should probably zoom into here. The unit of time is seconds. So the graph is talking about each second as a second goes on. And then your eye should zoom into here. So here you're talking about well, the unit of speed is meters per second. So when you're given any graph in general, look at this bit here and look at this bit here, just to get a rough idea of what the graph is talking about. Okay, now we know that this graph is talking about speed against time. So let's just imagine you sitting in a car with your dad at the moment. You and your dad are at rest, meaning you're not moving. So at time equals 0, so you are here at the moment, okay, and here at the moment. At time equals 0, your speed is 0. That means, well, you're not moving, so your speed is 0 here. Okay, so at time equals 0 here, you and your dad are not moving. So let's say from 0 to 4 seconds here, your dad is going to put his foot on the accelerator. That means he's going to accelerate. Now, accelerate means there's a for the time being, accelerate means there's an increase in speed. So when your dad puts his foot down on the accelerator, it means there's an acceleration. That means there's an increase in speed each second, or as time goes on. So if your dad puts his foot on the accelerator, your car's going to go faster and faster and faster, which means that there's an increase in speed. Okay, so from 0 to here, your dad is going to put his foot on the accelerator. Now look at this. If he puts his foot on the accelerator, it means that his speed is increasing. So you can see it's increasing each time. As time goes on, the speed is going to increase. And the thing is, if look at this here, in 2 seconds, your dad would have increased his speed by 1 meters per second. So what that means is, if between 0 and 4 here, there's an acceleration because your dad put his foot on the accelerator, so there's an acceleration. But this acceleration here is actually well, the gradient of this represents the acceleration. Let's just work this out. The height here is 2. The across here is 4. So 2 divided by 4. Okay, let's just say, okay, his acceleration is a half. Okay, so his acceleration A is a half. Now, what that means is every second his speed will increase by a half. Okay, so here, look at this. 1 second, his speed has increased by a half. So it was 0, and now it's a half. And then after another second, the speed has increased by another half. So after 2 seconds, it would have done 1 meters per second. And then after another second, his speed would have increased by another half, and so on. So when you're given a speed time graph like this, the gradient actually represents the acceleration. Okay, acceleration. Okay, so the gradient here, it represents acceleration. So from 0 to 4, there's an acceleration. The acceleration is a half. But the thing is, a half what? Now look at this. We've just established that acceleration equals the gradient of this line. Now, how did we work out the gradient? We got the height divided by the across, if you like. So the height here is 2. Okay, the across here is 4. So the gradient is 2 divided by 4. Now let's look at the unit. Now the height here, we are talking about speed. The up and down here is actually the speed, which is measured in meters per second. So the up and down here is meters per second. Okay, and remember this can be written as this as well, or it can be written as this, meters per second to the -1. So I chose to visualize this as this. So now let's look at this. The up and down here represents the speed. So the unit of speed is meters per second. And then you're going to divide it by the across here. The across here is time, and that's measured in seconds. So now we are going to get, well, remember that this is in seconds, okay? Now the gradient, you would get this thing divided by the second here. So let's get this thing, which is m over s, and then divided by s, okay? So now you're dividing a fraction, so it gets multiplied to the bottom. So it becomes meters per second squared, or you can choose to visualize it like this. Okay, that's why the unit of acceleration is this. So hang on. So between 0 and 4, between 0 and 4 seconds, the acceleration is a half meters per second squared. Okay. Yeah. So just accept that when you're given a speed time graph, the gradient, the steepness represents the acceleration because there's a change in speed. There's an increase in speed, so there's an acceleration. So the minute your dad puts his foot on the accelerator, that means there's an acceleration. Okay. Now between 4 and 9 seconds here, there's no acceleration. So your dad is traveling at a constant speed of 2 meters per second. Okay. Now at 9 here, at 9 to 11, well, 2 seconds, for 2 seconds, your dad has put his foot on the accelerator again, and that means that there's an increase. When there's an acceleration, it means there's a change in speed. So in this case, there's an increase in speed here. If you look at this here, the gradient is actually 3 here over 1, or you can use this triangle here to work out the gradient. If between here and here, you can use a big triangle here, which is 6. The up and down here is 6. The across here is 2. So the acceleration would be 6 divided by 2, which is 3. Or you can use this triangle here. Again, the acceleration is 3 over 1. Again, it's still the same. 3 meters per second squared. Okay. My point is that at this point here, the acceleration of the car is the same as the acceleration here. Okay. Or the acceleration of the car here is exactly the same as the acceleration right at this point here. Okay. So well, it's all 3 meters per second squared. Here the acceleration is 0.5 meters per second squared. Okay, so between 11 seconds and 14, there's no acceleration. So the acceleration is 0. It means that your dad is traveling at a constant speed. There's no acceleration, so there's no change in speed. There's no increase or there's no decrease. There's no change in speed. So, well, the acceleration is 0 here, between here and here. Now, between here and here, between here and here, to work out the grade, to work out the acceleration, just get the height divided by, well, the height here is 3 divided by the across here is also 3. So 3 divided by 3, the acceleration here is 1 meters per second squared. And by the way, the acceleration here is still 1. The acceleration here is still 1, and the acceleration here is 1. Now the acceleration here is 0. Okay. And the other thing is, if you want to work out the total distance traveled, let's say between 0 and let's say 9 here. Okay. Then work out the area underneath this thing here. So you would need to work out the area of this plus the area of this, okay, which I will show you in the next video. Or if you want to know how far did your dad travel between 11 seconds and 14. So basically between here and here. So it amounts to you working out the area of this bit here. If you want to know how far the distance traveled between 11 and 14, then you will work out this thing here. Okay, and by the way, every time you work out the area of something, let's say hang on, let's say you've got this here, the speed here. Hang on, speed time graph here. Time is measured in seconds. Speed is measured in meters per second. Let's say your dad's traveling at a constant speed. If you work out the area of this, then you are basically getting the up and down here. Now the unit of the up and down here is meters per second. Now if you're working out the area of this thing here, then you would get the across here. The units of the across here is seconds. Okay, so when you work out an area, you would get this times this. That means you get this times this. Now what does it mean when you get this times this? Well, look at the unit. Here you've got meters per second, which is this here, and then you times this second here. So here you've got you're multiplying a fraction, so it gets multiplied to the top. So this equals meters times second over second. So these two will get killed off, leaving you meters. So when you work out the area of a speed time graph, what you will get will be what's measured in meters, which happens to be distance. Okay, so when you are given a speed time graph, if you work out the area underneath the speed time graph, it actually represents distance. Because it just represents distance. And by the way, if you want to know the distance traveled between 0 and 4, then work out the whole rectangle here, and then cut it in half, and then divide it by 2. Okay? Well, work out the whole rectangle here, and then divide it by 2. Okay? Actually, in the next video, I will give you some practice, and then I will teach you some more. Okay?